Hello everyone, welcome to SysGuide's YouTube channel. In this video, I'll show you how to properly install KVM on Linux distributions, such as Fedora, Rocky, Ubuntu, Debian, and Arch Linux. I will briefly explain the essential components of KVM virtualization and what packages are necessary for running and managing Linux and Windows virtual machines. I'll show you how to use the modular Libvirt daemon rather than the monolithic daemon. I'll also show you how to use tuned to tune your physical host machine. In addition, I will demonstrate how to configure a network bridge on your host machine so that the virtual machine is accessible from the outside world. Finally, I'll demonstrate how to grant the user system-wide permission and set ACL on the images directory. To ensure you don't miss out anything, make sure to watch the video all the way through. So let's get started. The KVM, that is kernel-based virtual machine, is a Linux hypervisor that supports full virtualization. When you install KVM on Linux, your Linux distribution is transformed into a Type 1 hypervisor, allowing you to run virtual machines at near host machine speeds. A Type 1 hypervisor, also known as a bare metal hypervisor, interacts with the underlying machine hardware directly rather than through an operating system. KVM virtualization has three main components that you should be aware of and why they make virtual machines run faster. The first component, and also the heart of KVM virtualization, are its kernel modules. The kernel modules will use the hardware-assisted virtualization capabilities of the CPU to transform Linux into a Type 1 hypervisor. This allows you to run desktop operating systems at speeds close to those of the host machine. They consist of a loadable kernel module KVM.ko, which provides the core virtualization infrastructure, and a processor-specific kernel module KVM Intel.ko or KVM AMD.ko. However, since kernel modules lack an interface, they provide all the resources necessary to manage virtualization for user space software. And this brings us to the second important component, which is QEMU. QEMU is a generic and open source machine emulator and virtualizer. It provides hardware emulation like hard disks, network cards, VGA, PCI, etc., and a low-level interface to the virtual machine. QEMU alone can emulate an entire machine, including a processor and various devices in the software, with no need for hardware-assisted virtualization. As an emulator, QEMU may thus target a broad range of computer architectures, from conventional x86-64 PCs to architectures such as ARM, MIPS, SPARC, and others. For example, on your host PC with a x86-64 board, you can run a virtual machine that can emulate the Raspberry Pi with a Raspberry Pi 3B board. However, because this emulation is done entirely through software, it will be slow. But when QEMU is paired with KVM, it's a different story altogether. In the QEMU KVM setup, QEMU focuses on emulating hardware devices while allowing the hypervisor, that is KVM kernel modules, to manage the CPU. With hypervisor support, QEMU may reach virtual machine CPU performance as near to that of the host computer. And finally, the third key component of KVM virtualization is Libvirt. The Libvirt is a software suite that provides various tools to manage virtual machines and other virtualization functionality. These tools include an open source API, a daemon, and a command line utility Virsh. Some of the key capabilities of Libvirt include virtual machine management, remote machine support, network and storage management, as well as virtual NAT and route-based network management. Libvirt also provides a common means of managing multiple different virtualization platforms. Supported virtualization platforms include QEMU KVM, Hyper-V LXC, VMware ESXi and GSX, VMware Workstation, VirtualBox, Zen, and many others. Okay, now that you know what the key components of KVM virtualization are, let's move on to installing KVM virtualization on your computer. I'm going to demonstrate this video using Fedora as my host operating system, which is running on my physical hardware. The same commands work with other Red Hat-based Linux distributions, such as Rocky, Alma, and Oracle as well. If you're using Ubuntu, Debian, or Arch, I'll also show you what commands to use. First, determine whether your hardware supports KVM virtualization. If your hardware isn't supported, you'll get errors when attempting to run a virtual machine. Your processor must support hardware-assisted virtualization. It will be either Intel's VTX or AMD's AMD-V. I'm using an Intel processor, so I'm getting VTX as output. If you have an AMD processor, the output should be AMD-V. If the output is blank, the hardware virtualization extension is most likely disabled in the UEFI firmware. Before proceeding, enable it. It will be located in the CPU configuration section. Next, ensure that your kernel includes KVM modules. The module is only available if set to Y or M. If both steps are successful, proceed with the installation of KVM. To use KVM virtualization on Linux, you'll need 1 KVM kernel modules, 2 QEMU, and 3 the Libvirt software suite. Since Linux already includes KVM kernel modules, the only thing required for using the KVM hypervisor is the installation of QEMU and Libvirt. However, there are several other virtualization management packages that are recommended when using virtualization. These packages contain a variety of tools that assist you in managing your guest virtual machine more effectively. Virt-Install is a command line tool for creating guest virtual machines. Virt-Manager is a graphical tool for creating and managing guest virtual machines. Virt-Viewer is a graphical console for connecting to a running virtual machine. EDK2 OVNF enables UEFI support for virtual machines. SWTPM is a TPM emulator for virtual machines. QEMU ING provides tools to create, convert, modify, and snapshot offline disk images. GuestFS Tools provides a set of extended command line tools for managing virtual machines. LibOS Info is a library for managing OS information for virtualization. And finally, TuneD is a system tuning service for Linux. Press Enter to install the packages. Next, if you want to run virtual machines with Microsoft Windows operating systems, you must also install VirtIO drivers. VirtIO drivers are para-virtualized drivers for KVM guests. Microsoft, unfortunately, does not provide VirtIO drivers. As a result, you must download the VirtIO Win ISO image, which contains the VirtIO drivers for Windows. If you're using Fedora and other Red Hat-based Linux distributions, you'll need to install the VirtIO repository before installing the VirtIO Win.iso image. So let's do it. Download the VirtIO repository file to /etc/yum.repos.d directory. By default, you can only install the stable version. If you want the most recent package, you must enable it in the repository. Open the VirtIO win.repo file. Go to VirtIO Win Latest section and enable repo by replacing 0 with 1. And now install the VirtIO Win package. The VirtIO Win ISO image will be saved in the /user/share/VirtIO Win directory. For Linux distributions that are not based on Red Hat, you can directly download the most recent version of VirtIO Win ISO from the website. I'll include the link in the description. When you create a Windows virtual machine, you need to attach this ISO image to a CD-ROM. It includes all the VirtIO drivers necessary for Windows OS installation. Now that you have installed all the necessary packages, the Libvirt daemon must be enabled. There are two types of Libvirt daemons, monolithic and modular. The type of daemon you use affects how granularly you can configure individual virtualization drivers. The traditional monolithic Libvirt daemon, Libvirt-D, manages a wide range of virtualization drivers via a centralized hypervisor configuration. However, this may result in inefficient use of system resources. In contrast, the newly introduced modular Libvirt provides a specific daemon for each virtualization driver. And as a result, modular Libvirt daemons offer more flexibility in fine-tuning Libvirt resource management. While most Linux distributions have started to offer a modular option, at the time of video recording, Ubuntu and Debian continue to offer only a monolithic daemon. So to enable Libvirt modular daemons for Fedora, Rocky, and Arch Linux, go to my webpage on the same topic, copy the command, and paste it into your terminal. For Ubuntu and Debian Linux, use this command to enable the monolithic Libvirt service. And finally, reboot your system so that the KVM can properly start After the reboot, verify that your host is correctly configured to run all Libvirt hypervisor drivers. As you can see, the majority of the tests have passed, except for these two warnings. If you receive this warning and your processor is Intel, you can safely disregard it. It only applies to AMD processors. If you have an AMD processor, please visit this link to fix this warning. I'll include the link in the description. If you see this warning, it means your Intel CPU supports VTD, but it must be enabled in the kernel. To enable VTD, open the /etc/default/grub file and add the options Intel_IOMMU equals on and IOMMU equals PT. Save the file and exit. Regenerate the grub configuration file. And finally, reboot the system. Once the system has booted, validate the host again to ensure that no problems remain. The next step is to use TuneD to optimize your host system. TuneD is a system tuning service for Linux. It provides a number of pre-configured tuning profiles, each tailored to specific workload characteristics. This includes CPU-intensive job requirements, storage and network throughput responsiveness, and reduced power consumption. So let's enable and start the TuneD service. Find out which TuneD profile is currently active. As you can see, the current active profile is balanced. Balanced is a TuneD profile that is generic and not specialized. It is not an ideal profile for a KVM host, so you must change the profile. First, list the profiles provided by the TuneD service. I will set the profile to virtual host. This optimizes the host for running KVM guest virtual machines. Verify that the TuneD profile has been updated and that the virtual host is now active. Make sure there are no errors. Your host is now optimized to run KVM guest virtual machines. With the TuneD service already enabled, let us focus on configuring a network bridge. By default, all virtual machines running on the host connect to the same NAT type virtual network named default. All virtual machines that connect to this default network will be assigned an IP address from a specific range of IP address space. In my case, the assigned IP address will be between 2 and 254 in the 192.168.124.0 subnet. Virtual machines using this default network will only have outbound network access. Virtual machines will have full access to network services, but devices outside the host will be unable to communicate with virtual machines inside the host. For example, the virtual machine can browse the web, but cannot host a web server that is accessible to the outside world, not even from your own mobile phone on the same network. If you want virtual machines to be directly visible on the same physical network as the host and visible to external devices, you must use a network bridge. Network bridge is a link layer device that connects two local area networks into one network. In this case, a software bridge is used within a Linux host to simulate a hardware bridge. And as a result, all other physical machines on the same physical network of the host can detect and access virtual machines. The virtual machine, for example, can browse the web and will also be able to host a web server that is accessible to the outside world. So let's create a network bridge. First, find the name of the interface you want to add to the bridge. In my case, it is ENP to S0. Create a bridge interface, NMCLI connection add, type bridge, connection name, bridge 0, interface name, bridge 0. I'll name the connection and interface as bridge 0. You can call it whatever you want. Next, add the Ethernet interface to the bridge. An MCLI connection, add, type Ethernet, slave type, bridge, connection name, bridge, connection 1. I'm going to name this connection bridge connection 1, but you can name it whatever you want. Interface name, ENP2S0, master bridge 0. Activate the connection. Enable the connection .autoconnect -slaves parameter of the bridge connection. Reactivate the bridge. Verify the connection once more. As you can see, bridge 0 device has been created. It may take a few seconds to connect. Please give it some time. The network bridge has now been created. You can now start using a network bridge when creating virtual machines. However, it is recommended that you also set up a virtual bridge network in KVM so that the virtual machines can use this bridge interface by name. So create an XML file called nwbridge.xml. Add these XML elements. This network bridge will be known as nwbridge in KVM. You may rename it if you wish. The name of the bridge will be the one you just created. So that's bridge 0. Save the file and exit. Using this XML file, define NW Bridge as a persistent virtual network in KVM. Start the NW Bridge virtual network. Also, make the NW Bridge virtual network auto start every time the computer boots. Now you can safely delete the nwbridge.xml file. It's not required anymore. Finally, list all of the virtual networks in KVM. And as you can see, the NW Bridge network bridge is now available for use alongside the default virtual NAT network. You can now start using the NW Bridge in your virtual machines. The virtual machines will get their IP addresses from the same pool as your host machine. If you ever want to remove this network bridge and return it to its previous state, then run these commands. I'll include a link to this web page in the description. The next step is to grant system-wide permission to regular user. Libvirt has two modes for connecting to the local KVM hypervisor: session mode and system mode. In session mode, a regular user is connected to a per-user instance. This mode allows each user to manage their own pool of virtual machines. This is also the default mode when running a virtual machine as a regular user. The advantage of this mode is that permissions are not an issue because no root password is required. This mode better integrates with desktop use cases. Gnome boxes use this mode by default. The disadvantage is that this mode uses QEMU user networking, which is implemented by using Slurp. This is a user space IP stack. So there will be a lot of overhead resulting in poor network performance. Moreover, if you want to implement an option that requires root privileges, you will be unable to do so. Unfortunately, to run a virtual machine with full virtualization, you need a lot more options that require root access. This brings us to the second option, which is system mode. This mode connects to a system instance as the root user locally. When run as root, it has full access to all host resources. This is also the recommended mode for connecting to the local hypervisor. This is also the default mode for Virt-Manager. So if you want to complete access to all host resources, you should connect to a system instance. First, add the regular user to the Libvirt group. As you can see, the regular user is now a member of the Libvirt group. Next, open the user's local.bashrc file and set the environment variable Libvirt default URI to system instance. Save the file and exit. Source the file. Now check again as a regular user to see which instance you are connected to. You can now use the VRSH command line tool and the virtual machine manager without sudo and have system-wide permission with full access to all host resources. The last thing you should do is set up ACL for the images directory. By default, virtual machine disk images are saved in this images directory. This directory is only accessible to the root user. As a regular user, you might want to have access to this directory without having to type sudo every time. The best way to access this directory without changing the default permissions is to set the ACL for it. So first, recursively remove any existing ACL permissions on the directory. Next, recursively grant regular user permission to the directory. Replace the username with your own. The capital X indicates that execute permission should only be applied to child folders and not child files. The regular user can now access all existing directories and files in the images directory. However, any new directories or files created within the images directory will not have this ACL set. And to get around to this, we need to enable default special permissions. The default ACL can only be applied to directories and not to files. Now review your new ACL permissions on the directory. As you can see, the regular user now has full access to the images directory. Now, as a regular user, try to create a file in the images directory. And you now have full access to the images directory. You can now manage virtual disks manually without root privileges. Okay, this brings us to the end of the video on how to properly install KVM on Linux. In the upcoming videos, I will show you how to create Linux and Windows virtual machines using Virt-Manager. So stay tuned.